Next comprehension problem is, consider fx is defined as root over 1 minus x square when x is greater than or equals to minus 1 to less than 0, x square plus 1 when x is greater than or equals to 0 to less than 1, and x minus 1 whole square divided by 4 plus 2 when x is greater than or equals to 1. One more function g is defined such that g of f of x equals to x for all x is greater than or equals to minus 1, and f of g of x equals to x for all x is greater than or equals to 0. Based on this one, there are three problems. First problem is the range of the function f of g of x is, and second problem is the domain of the g of f of x is, and the third problem is the number of the solutions of the equation fx equals to gx is. Now we will draw the diagram of fx. Fx is defined from minus 1 to 1, but it will break at 0 and 1. So we have to check whether at 0 and 1 it is continuous or not. To check continuity, we have to find out limits. So we know left hand side you have to check. So limit x tending to 0 minus, that is LHL. Limit x tending to 0 minus left hand side of 0 function is what? Root over 1 minus x square. If I put 0, we will get what? 1. Similarly, right hand side RHL. Limit x tending to 0 plus right hand side graph is what? X square plus 1. So if I check x square plus 1, if you put 0, what you will get? 1. And function value at 0 also will come as 1. So we can say fx is continuous at 0. Similarly, we will check at 1 also. So limit x tending to 1 minus, that is LHL. So left hand side of 1 is x square plus 1. So what value you will get? 2 we will get. Similarly, RHL. Limit x tending to 1 plus right hand side is what? X minus 1 whole square divided by 4 plus 2. So if I put 1, we'll get 2 only, and f of 1 equals to also will come 2. So that means we can say fx is continuous at x equals to 1. Now we can say fx is continuous. Now we will check differentiability of fx. To check differentiability, we will differentiate fx. So fx is defined as root over 1 minus x square when x is greater than or equals to minus 1 to less than 0. So we will differentiate this one. So root over 1 minus x square differentiation is what? 1 upon 2 root 1 minus x square. Then inside 1 minus x square differentiate what? Minus of 2x. So what we will get? We will get minus x by root over 1 minus x square when x is minus 1 greater than or equals to less than 0. And x square plus 1 differentiation what? That will come as 2x where x is greater than or equals to 0 to less than 1. And this one differentiation we can do, that will come what? 2 times of x minus 1 divided by 4 plus 0, that will come what? X minus 1 divided by 2 where x is greater than or equals to 1. Now we will find out limit, we will check for f dash x. So limit at x equals to 0 minus, what is the function? Function is what? Minus x divided by root over 1 minus x square. At x equals to 0, if you check, what will get? 0. Similarly, right hand limit we will check. Limit x tending to 0 plus, what will come? At 0 plus, what is the function? 2x. So what will get? 0. So f dash x limit exists at 0, then we can say fx differentiation is possible at x equals to 0. Similarly, for 1 also we'll check. So limit x tending to 1 minus f dash x function is what? 2x. So what will get? 2. Similarly, right hand limit if you check of f dash x, limit x tending to 1 plus right side function is what? X minus 1 divided by 2. So what function will get? 0 will get. That means what? At 1 it is not differentiable. So function is differentiable at 0. So function is continuous at 0 and it will be smooth. But function is not differentiable at x equals to 1. But we can say it is continuous, but it is not. A smooth curve will be there. Now we can say fx is continuous and differentiable at x equals to 0, not differentiable at x equals to 1. The next thing is required is concavity. We know if I take d2y by dx square is greater than 0, then curve is concave upward. And if I take d2y by dx square is less than 0, then curve is concave downward. Now first we will check y equals to root over 1 minus x square, where x belongs to closed interval minus 1 to open interval 0. So y dash. So root x differentiate what? 1 upon 2 root 1 minus x square. So inside differentiate what? Minus of 2x. So what will get? Minus x divided by root over 1 minus x square. Then y double dash. For y double dash, minus we can take outside. Denominator is square. So root over 1 minus x square whole square. Denominator is outside, 1 minus x square. Differentiation of x is what? 1 minus, numerator is outside, denominator differentiation what will come? Minus of x divided by root over 1 minus x square. Now we will simplify. So y double dash equals to what? Minus of root over 1 minus x square. This minus minus become what? Plus x square divided by root over 1 minus x square divided by 1 minus x square. So we can write y double dash is nothing but what? Minus of 1 minus x square plus x square divided by 1 minus x square. So y double dash equals to what will come? This x square getting cancelled. Minus 1 divided by 1 minus x square. So y double dash equals to what? 1 upon x square minus 1. We know x is what? Belongs to minus 1 to 0. And x square minus 1 is what? Less than 0. So we can say y double dash will come less than 0. That means what? Y equals to root over 1 minus x square in the interval x belongs to minus 1 to 0 is concave downward. So this is concave downward. Next is y equals to x square plus 1, where x belongs to closed interval 0 to open interval 1. So y dash what will come? 2x, and y double dash will get 2. So y double dash is what? Greater than 0. That means concave upward. Similarly, we will check y equals to x minus 1 whole square divided by 4 plus 2. So y dash what will come? 2 times of x minus 1 by 4 plus 0. And y double dash what will come? 2 by 4, that is 1 by 2. So y double dash is also greater than 0. So this is also concave upward. Now we will draw the diagram. Now we will draw the diagram of fx. When x is minus 1, so at minus 1, y will be what? 0. So this point is what? Minus 1 comma 0. When x is 0, you will get what? 0 comma 1. And if I put x equals to 1, what will get? 2. So at one point you will get what? X equals to 1, you get what? 1 comma 2. We can say minus 1 to 0, curve is concave downward. So this curve will come like that. After 0 to 1, concave upward. And after 1 also it will be concave upward. So this is graph of y equals to fx. Rough graph we are drawing. Next is what? Given is what? G of f of x equals to x. So from there we can say fx is nothing but what? G inverse of x for all x is greater than or equals to minus 1. So that means we can say this fx is nothing but what? G inverse of x, and domain of this one also what? Greater than or equals to minus 1. And second thing is given is what? F of g of x equals to x. So from there we can say g of x equals to nothing but f inverse of x. So for finding g of x, we will find out f inverse of x. So fx and f inverse x, we can say these two graph is mirror image with respect to y equals to x. So we will find out f inverse x graph. So we'll take mirror image of this graph. So we know this point is minus 1 comma 0. So mirror image will come as 0 comma minus 1. This point is 0 comma 1. It will come what? 1 comma 0. This point is 1 comma 2. Mirror image will come at 2 comma 1. Now from there we can say this is concave downward. Here will come concave upward, and here will come, this will come concave downward, and again this will come concave downward. So this graph is what? Nothing but y equals to g of x or f inverse of x, and this graph is what? Y equals to fx and g inverse of x. Now we will solve the problems. Now we have to find out the range of the function f of g of x. That means we have to find out outside function values. Inside function is given g of x, correct? So we will start from inside function. So inside is what? G of x. So we know g of x range is nothing but what? If I take x belongs to closed interval 0 to infinity, then g of x range will come what? G of x belongs to minus 1 to infinity. Now we have to apply f. what will become f of g of x. For with respect to f, g of x become domain and g of x value is what? -1 to infinity. So that means we will see the graph of f from -1 to infinity. So if I check -1 to infinity, that f function lie from 0 to infinity. So f of g of x we can say close interval 0 to infinity. Again if I apply f, so f of g of x. Now f of g of x value is what? Close interval 0 to infinity. Now we'll see again f graph from close interval 0 to infinity. So if I see 0 to infinity graph, so value of f is what? 1 to infinity. So we can say f of g of x belongs to what? Close interval 1 to infinity. Next again if I apply f, so what will come? F of g of x. Now in this one f of g of x value is what? 1 to infinity. Now again we will see the graph of f from 1 to infinity. So if I check 1 to infinity, the value of f will come 2 to infinity. So we can say f of g of x lie from 2 to infinity. So range of this function should be what? 2 to infinity. So D is the correct option. Next is the domain of g of fx is. So we know maximum range of g is what? -1 to infinity. So for that we have to find out x value, so that outside function g range should become -1 to infinity. So we can say g of fx lie from where to where? Close interval -1 to less than infinity. Now we'll take inverse. So g inverse -1 is less than equals to g of f of x is less than g inverse of infinity. We can say g inverse of infinity is what? Infinity only. G inverse of 1. This function is nothing but y equals to g inverse of x. So if I put -1, so g inverse of -1. So at -1 what value you are getting? Y? 0. So this value will come as 0. So 0 is less than or equals to g of f of x less than infinity. Next again we will apply g. So this will come as g inverse 0 less than equals to g of f of x less than g inverse infinity. So g inverse is 0. So if I put 0 here, so at 0 what value you are getting? 1. So this will come as 1 is less than equals to g of f of x less than infinity. Again we will apply g inverse. So g inverse 1 is less than equals to fx less than g inverse of infinity. So again if you put g inverse 1, if I put x equals to 1, at x equals to 1 y value is nothing but 2. So this will come 2 is less than equals to fx is less than infinity. Again if you apply f inverse, so f inverse 2, this will come what? X, and this will come f inverse infinity. So f inverse 2, so this function is what? F inverse x. So if you put 2, so f inverse 2, that means at 2 what value you are getting? 1. So we can say 1 is less than equals to x less than infinity. So domain of this function is what? 1 to infinity. So C option is correct. Next problem is the number of the solution of the equation fx equals to gx is r. So to find out number of solution of fx equals to gx, we know gx is nothing but what? F inverse of x. So we have to find out fx equals to f inverse x number of solution. So we have to find out y equals to fx. So and other graph is what? Y equals to what? F inverse x. So intersection point of fx and f inverse x. We know fx and f inverse x is mirror image with respect to y equals to x. So if fx intersect y equals to x, at same point f inverse x also will intersect. That means to find out solution, we will do what? Y1 equals to fx and y equals to x. We have to find out solution of y1 equals to fx and y equals to x instead of f inverse x. Now first we will simplify y equals to root over 1 minus x square, where x belongs to what? Close interval -1 to 0 and y equals to x. If you simplify and if you are getting the values of x lying between -1 to 0, so if you get negative value, but we know g of x should be what? Greater than equals to 0. That means there is no values of x. For that these two functions will intersect. That means what? We no need to simplify for this one. From there we will not get any solution. Next is what? X square plus 1. So y equals to x square plus 1, where x belongs to what? Close interval 0 to open interval 1 and y equals to x. Here solution can be possible because g of x is what? X domain is what? Greater than equals to 0, and this one also positive. So if I simplify x equals to what? X square plus 1. So x square minus x plus 1. If we see this one discriminant is what? Less than 0. So there is no solution. The last is what? If I take y equals to x minus 1 whole square divided by 4 plus 2, where x is greater than equals to 1 and y equals to x. So if I simplify here, so x equals to x minus 1 whole square divided by 4 plus 2. So what will come? X minus 2 into 4 equals to x square minus 2x plus 1. So from there, if I simplify, x square minus 6x plus 9 equals to 0, x minus 3 whole square equals to 0, we will get x equals to 3. And we know x equals to 3 lies between in the interval of x is greater than equals to 1, and x equals to 3 is also possible for g of x. So 3 will lie on domain of g of x as well as in fx. So that means what? 3 is a solution. So answer is 1. So B option is correct. Number of solution is 1.